str, we are going to move append on append. Okay, so we are going to add element inside the linked list. Append means we are going to element from the end. Okay, so initially we have empty linked list. Okay, we are going to add 10. Okay, so linked list will become with one node. Okay, this is the tail. Sorry, this is the node and this is the head and this is the tail of linked list. Okay, again I am going to add 20 after 10 because we are going to add an element in the end. Okay, so 10, 20, null, null, or you can say this is for head and this is for tail. Okay, again I'm going to add 30. So after 10, 20 and 30, here I added 30. Okay, so here you can see I am going to add 40 after 30, so this will become like this. Okay, so we are going to add element after the, I mean you can say in the end. Okay, so each append maintain forward link. Okay, 10, 20 and 30 each. Sorry, backward link, it is also have forward link and backward link 10, 20, 30 and 40. Okay, head point to the 10 because it is first element and tail point to the last element, that is tail, that is 40. Okay, so here I am going to create code for append method. I'm going to define one function, that is append. Okay, here I am going to pass self comma value column. Here I am going to pass new node, new underscore node equals to node, new node equals to node, and here I am going to pass value. Okay, this is the new node I am going to create like this. Create a new node. Okay, so here new node equals to, I am giving anything. Okay, 30, whatever is it, 30. Okay, and here I am going to write one condition, if not self dot head. Okay. So if you have linked list like this, 10 and 20. Okay, so if you have linked list 10, 20. Okay, guys, it has both element forward or backward. Okay, like this. 10, 20. Okay, one for forward, one for backward. Okay, I am going to add 30 after 20 here. Okay, so here I am going to create new node, that is 30. I am going to add here after 20. Okay, so you can see here head is 10, first element, and tail is 20. New node, that is 30. I am going to add here. Okay, so tail dot next, we don't have any element as of now here after tail, so tail dot next equals to nothing. New node dot previous. Okay, so I haven't add 30 here. Okay, I want to add 30. Okay, this is the new node. So new node dot previous, we also don't have anything. Okay, this is the new node 30. Okay, so here I'm going to check head is not none because we have 10 here. Okay, so now head equals to 10 and tail equals to 30. New node is also 30. Okay, so here after this line, if not self dot head. Okay, if you don't have any head, but we have head, but I'm going to write this condition, if you don't have any head inside the linked list, then you write like this. Okay, new node, so it will be add first element inside your linked list. Okay, this is for tail is equals to new node self dot tail, and you can add both element. Sorry, you can add tail and head for new node. Okay, and if element are already present in your linked list, then you use else condition, that is this. Okay, so here I am going to write self dot tail dot next is equals to new node. new underscore node. Okay, so here new underscore node dot previous, new underscore node dot previous equals to self dot tell. Okay, and here I will explain. Oh, wait a minute. Self dot tell is equals to new node. Okay, guys. So after this, okay, head is not empty. Okay, head is not empty. Okay, we have already element inside the head. These are the element 10 and 20. I am going to add this 30 with 20. Okay, so here I am going to find out tell dot next equals to new element, new node. Okay, so here self dot tell dot next equals to new node. Okay, so here you can see self dot tell means what we have in tell 20. Tell dot next what we have 20. So here I am going to add 20 dot next is equals to new node, that is 30. Okay, so after adding this 20 with 30, it will become like this: 20 connect with the 30, like this. Okay, link old tell to new node. Okay, 20 connect with the 30 by using this line. Okay, self dot tell dot next means we have this 20 dot next. Okay, and it connect with the 30 here outside. Here you can see here after 20. Okay, now now new node dot previous, it means new node dot previous equals to tell. Okay, so I have had equals to 10, tell equals to 20, new node equals to 30, and tell dot next equals to 20 connect with the 30. Okay, so new node dot previous. So what we have in previous? 20. So here new node is, what is the new node? New node is 30. 30 dot previous is equals to tell. So what we have in tell? Tell is 20. Okay, because before adding we have tell, that is 20. Okay, one new node is 30. So here you can see new node dot previous self dot tell. Okay, so here previous will connect with the 20. Sorry, new node connect with the 20 previous, like with the uh, backward arrow. Okay, so this 30 connect like this. Okay, next means it connect like this. Okay, and tell means it connect like this. Sorry, next means it connect like this. Okay, and previous means is connect like this. Okay, guys, I couldn't actually, I am unable to write, so this is for next, and this is for next and previous. Okay, this is for 30 is connected to the 20 with previously by using previous. Okay, so 30 is connect with the 20, and here, so link new node back to the old. Okay, and now tell self dot tell. Okay, it's mean, sorry, here self dot tell equals to new node. Okay, so here self dot tell equals to new node. Now our tell will become 30. Before we have 20. Okay, so new node will be our new tell. This is the new tell. Okay, guys, I hope you got it. So this is just a program. Okay, self dot tell dot next. Okay, so you need to find out, you need to connect here element before. Okay, we don't have suppose we don't have 30 here, so we need to connect by using like this. Okay, self dot tell dot next equals to new node, and new node, you want to connect this new node by previous element, previous pointer. So new node dot previous equals to self dot tell. Okay, and self dot tell equals to new node. And here I have already created this class. Okay, so I am going to create object for double linked list class. Okay, so here double linked list, I'm going to append this method here, that is append, and this is the object of double linked list class. Okay, this class, double linked list class. Okay, so here initially you don't have any node and tail. Node, you can say, head on tail, you don't have any. Also both are none. Okay, so you need to create object of this. Okay, so here I am going to append dll dot append, that is 10, and print dll. Okay, so you got 10, or you can append multiple element here. Okay, like 30, 20, and 30. Okay, so you got 10, 20, and 30 like this. Okay guys, so this is our double linked list. Okay, now we are going to move prepend. Okay, so append means we are going to add element in the end, or prepend means in the beginning. I am going to add element in the beginning, and the beginning of linked list means before the head. Or in append we are going to add element after the tail. Okay, here I'm going to add element before the head. Okay, so here I'm going to define one function, prepend. Inside this I'm going to pass self, and here value, column, here new underscore node equals to new underscore node equals to node, here value. Okay, so if node, so this is the function. Okay, and here I'm going to create new node. Okay, so first of all I have this linked list 10, 20. Now I am going to add 10 here. Okay, so create new node, that is 10, this one. Okay, so its value is 10. Now you can see here self dot head equals to new underscore node, means head is the new node. Okay, because we are going to add in the head. Okay, so here like I forget to write one line here. If we not self self dot head. Okay, so I just need to copy this line from here. Okay, if not self head, means if head is not present, then you need to create one variable self dot head and another variable self dot tail and assign the new node. Okay, that it will create a linked list of one node that has tail, same tail and head. Okay, otherwise if you have head inside your linked list, or if you have multiple elements, okay, so here you need to write new node dot next. Okay, so inside this linked list I am going to create new node. Okay, so that is 10. I am going to add here. Okay, I need to copy this line. Okay, so you can see here in this line I am going to add 10. Oh, okay, here I can write. Okay, so in this line I already have this linked list. Okay, now I am going to I want to add this 10 with the 20. Okay, so this is our new node. This is the new node. Okay, so new node dot next. So here this is the new node dot next means arrow. Okay, so here I am going to write code new node dot next means 10 with arrow is equals to self dot head. It means new node, that is 10, new node dot next is equals to new node dot next equals to head means 20. Okay, so here I am going to connect this 10 with 20. Okay, and here I am going to write self dot head dot previous. Okay, so here after this line new node dot next equals to self dot head. Okay, so new node, our linked list will become like this: 10 is connected with the 20, or head will be our 20. Actually, initially we have head equals to 20. Now linked list will become like this: 10, 20, and 30. Okay, I add only next pointer. Okay, now I am going to here, I am going to add here what? Previous point. Okay, so self dot head dot previous equals to new node. Okay, then it will connect like this. This will become like this. Okay, so because of previous, self dot head means 20 is connect with the new node. Okay, so here again self dot head dot previous. Okay, so self dot head means 20, we have 20, previous arrow, this arrow will connect it with the new node, that is 10. Okay, now after this line I am going to make self dot head. Now our head will be changed because previously I have 20, now head will become new node, that is 10. So our new head is 10. Okay guys, I hope you got it. So self dot head equals to new node, so head equals to 10. Okay, before what we have in head, that is 20. Okay, now our linked list will become like this: 10, 20, and 30. Okay, and after adding 10, okay, here after adding 10, linked list will become like this, and we need to increase its length by 1. Okay, because I add 1, sorry, I add, so here self dot length increase by 1. Okay, and here this is the prepend method. Okay, connected with the double linked list. Okay, so here this is the object of double linked list. I have already created double linked list class. Okay, this is the double linked list class, and it has tail and head both are none and length equals to 0. Okay, and here I am, this is the object, this is the object of double linked list class. I am going to append 10, 20, 30 in place of okay, previously I also append so here I am going to pretend, not append. Okay, pretend means we are going to add element before the linked list. Okay, that is 44 is the first element and last element is 5. Okay, and you can add multiple, so it will add before the linked list. Okay, before the head. So if you add anything here like 44 here 55, so 55 is the first element. Okay, now you can see append at the node at the end. If empty head and tail point to the new node, otherwise adjust the pointer tail dot next and new node dot previous and update the tail. Prepend value means add the node at the start. If empty head and tail point to the new node, otherwise adjust the pointer head dot previous and new node dot next equals to and update the head. new node dot next, okay, and update the next. So I am now, we are going to move traverse and reverse. Okay, so here traverse means we just print the linked list, or you can say we are we go, I mean we move one by one every node. We move on every node, like we will go from head to tail one by one and print the each element 10, 20, and 30. Okay, traverse means move from head to tail and print the each element. We move from head to tail inside the traverse. Okay, so here I am going to define one function, that is traverse, and here I am going write self colon. Here I am going to define one variable, that is current. Current equals to self dot head. Okay, while if you have current element, then while current underscore node. It's mean if you have element inside the current. Mm, this is the current node, yeah, or not current. Okay, so here you can see I have linked list like this 10, 20, 30 with previous and next pointer. Okay, so current node will be 10. Okay, also head equals to 10, but I am just write current equals to self dot head, means first element is the current. Okay, so here while current node, if you have element inside the current cells, we have, then we use while loop. Okay, then we are going to print current node dot value. Okay, and here after print the value, I'm going to end with quotes, single quotes. Okay, and here I'm going to write current node equals to current dot next. And here print. Okay, so wait a minute, we are going to traverse, okay, one by one. So current element is 10. Okay, so that is also head. Okay, so you can see here I have a current element inside the current, then we print the value of this current node. Okay, so here print the value like this in a string. Okay, so it will become 10 here. Okay, now current node equals to current dot next. So what we have after current? So we have 20. Current dot next, what we have? 20. So it will become our new current. Okay, so now current equals to 20. Okay guys, so here again you can check here. Okay, with 20, so current node dot value again 20. So it will write like this 10 and 20 here. Okay, and now current node equals to current node dot next, means next of 20 what we have? 30. So now current node will become 30 here. Current node equals to 30. Okay, again we can check with 30. So here current node dot value, so I'm going to add 30 like this. Okay, and linked list will become like this in visualization. Okay, and after 30 we can check current equals to current node dot next. So 30 is our current node, so next of this we have 40. Okay, so now 40 is our current node. Okay, then we can print current node value. So here it is 40, and we can end here because we don't have any other element after 40. Okay, so final output 10, 20, and 30 and 40, and it will give you like this in visualization. Okay, And here I can copy from here this line. Okay, this is for traverse equals to, it mean traverse is the double linked list method. Okay, so here if you want to print element by using traverse, okay, wait a minute. Actually I have already added multiple elements. So here this is the object of this double linked list class. Okay, here I already add pretend, means adding the before and adding the after. Okay, I can't use this because I haven't finished this. Okay, now we can traverse. Okay, so it will give you error, no reverse traverse. Okay, I don't have any traverse, reverse traverse. Okay, so if you are going to write, so it will give you linked list like this. Okay, so I already created pretend and append. Okay, so now I use traverse linked list, so it will give you like this output. Okay, I print this DLL 45, 44, 5 and 10. Okay guys, or if you want to remove these things, because I already add, so we can see here. Okay, this is empty linked list because we haven't any element. So now it will give you result. So initially it will give you 5, 4, 5 and 10. 54, 5 and 10. After this it will give you like this. Traverse, print the full list. Okay, so it will give you like this, and in visualization you got this result like this. Okay guys, now we are going to write code for reverse traverse. Okay, so here I am going to create one function df reverse traverse. Okay, here I am going to pass self. Oh, I forgot to put colons. Okay, now I'm going to write variable name, that is current underscore node. Current node equals to self dot tell. Okay, last element, because we are going to do reverse. Okay, so current element is the self dot tell. You can see here this is our linked list, double linked list. Okay, so 40 is the tell and this is the last element. So current element what we have, 40 here inside this. Okay, and I am going to write while loop. So if you have element inside the current node, okay, so current node, yes I have, then we use this loop. Sorry, when then we use this these things. Okay, print, it will write, I'm going to print current dot value comma, I'm going to end it with a what, single quotes. Okay, so if you have element, yes I have element inside the current, then we are going to print current dot value, that is 40 here. Okay, this is our 40. Now after adding 40 here, current node, current node equals to current node dot previous. Okay, guys, this is the totally opposite of traverse. Okay, here you can see I write current node equals to self dot head, but here you can see I have current underscore node equals to self dot tell, because we are going to reverse this. Okay, so while current nodes, okay, so I have current node, this is also same this line, while current nodes, okay, I am going to print current dot value. Okay, here I also I'm going to print current dot value. Okay, and current node equals to current node dot previous, and in traverse I use current node equals to, sorry, current node equals to current node dot next. Okay, we took next node. Okay, because we are going in forward direction, here we are going in backward direction, that's why I need to take previous here. Okay, after after 40 and previous, you can say 40 previous element of the 40, that is 30. Okay, so we moved in 30, so here our previous element is what, 30. Now what, current node will become 30. Okay, guys, and here print, I'm not going to print anything, print empty. Okay, and here you can see after 30, okay, this is the current node, I am going to check I have element in the current, so 30 will become our new current, then it will print. Okay, so it will, I'm going to add here after 40, that is 30. Okay, like this. Okay, now previous point of 30, that is 20. Okay, so here current node our 30 and previous of 30, that is 20. Okay, now current element is 20, so again current dot value, so 20, I am going to add 20 here. Okay, so I am going to check here current node equals to current node previous. Okay, so current node is 20, so previous of 20 is 10, so I am going to add 10 here, and current is equals to 10. Okay, like this, 20, 30 and 10. Okay, guys, and you can, like, if you are going to visualize, then it will give you like this, 40, 30, 20, 10. Okay, in the result. Okay, guys, I hope you got it. And after 10, you can see here I don't have any element. Okay, so none element, so final output 40, 30 and 10, like this. Okay, so this is our final output in print, and after this it will be, after 10 we don't have any element, so that's why it is none. Okay, and here I am going to write double linked list class. Okay, and this is the reverse traverse is the method of linked list. Okay, equals to reverse traverse, and here if you want to print this, then what you are going to use, guys, I just need to go here. Okay, so inside the reverse traverse you need to copy these things from here. Okay, then you need to write, oh, here. Okay, I already explained append, pretend. Okay, and I haven't explained insert, so I need to remove this. And you can see here I got this in reverse traverse, 10, 5 and 44. Okay, you can see here in traverse what we have, 45, 44, 5 and 10, it will become 10, 5 and 44. Reverse of this line, I got this. Okay, by using this. Mm-mm. Or you can print like this. Okay, so I got 45, 5 and 10. Mm-mm. Now, this is for traverse, 10, 5, 44. Okay, and this line is used for traverse, and this line is used for reverse travel. Okay, and this is for full linked list. Print all the full linked list. Okay, now traverse means move from head to tail and print each element, and reverse traverse means move from tail to head and print each element. Okay, now we are going to move on search and set and get. Okay, so here I am going to write code for search element. Okay, so I am going to define one function, that is search, serch search. Okay, here I am going to pass well parameters self comma target as a parameter. Okay, and here I am going to create one node, that is current node. Current underscore node is equals to self dot head. Okay, so you can see here I have linked list 10, 20, 30 and 40. Okay, I am going to search 30, that is target equals to 30, so I am going to search target, that is 30, inside this linked list. Okay, so current node is equals to self dot head. Okay, so this is our head of linked list. Okay, so this is also current, so here current equals to 10. Okay, and index start from 0, so index equals to 0. I'm going to use loop, so while loop, if you have current node, then you need to use these lines. Okay, or these conditions. If current node dot value equals to target. Okay, it's mean what do you have in current 10. Okay, so current node equals to 10, this is also had. Okay, so current node dot value is also 10, current node value here 10, and index is 0. You can check this 10 is equals to target is equals to 30. Here you already mentioned 30, so both are equal. No, both are not equal, so move to the next node. Okay, if both are equal, then what you are going to do, here you need to return index if both are equal. Otherwise, if both are not equal, then you move here. Current node is equal to current dot next. Okay, so I have current equals to 10. Now current dot next equals to 20. So it will become current node. Now 20 will become our current node. Okay, so here current node equals to current node dot next. What is the next node of 10? That is 20. Okay, because we already have current node equals to 10. Now next of the 10, what we have? 20. So now new current will become 20. Okay, that is the current node dot next. Okay, so here I am going to increase index by 1. Okay, and if you are unable to find out any index that is equals to target, then you need to return -1. Okay, so here after 20, this is our current node here 20. Now you can check this 20 available in at index 1, its index is 1. 10 is 0, 10 has 0 index and 20 has 1 index. Okay, so now you can check 20 is equals to 30 in this line. No, both are not equal, then we move here. Okay, again I'm going to find out current node. Okay, so now our current node is 20, so I'm going to find out next of 20 what we have, 30. So our new current node will become 30 and index increase by 1. Okay, so current node is 30 now. Here after 20 I have 30. Okay, so its index is 2. Now we are going to check value is equals to target. Yes, 30 equals to target, then it will return index equals to here, index equals to 2. Okay, you can see here current node, that is 30, is equals to target is also 30. Okay, and it will return its index here and return 2. Okay, I hope you got it. So here this is the linked list search. I am going to go again I'm going to move here, here. Okay, so we are going to search. For testing purpose. Okay, I am going to use these things, otherwise you are not able to understand. Okay guys, so here, double linked list. Search is method of double linked list, and here this is the object of linked list. Double linked list. Okay, here I'm going to pretend means adding the element before the head. Okay, here I'm going to add the element after the tail. I am going to remove this because I haven't uh, actually I haven't any insert. Okay, so that's why this is traverse, this is for reverse. Okay, and this is for search 99 in linked list. Okay, oh, I haven't finished this set also. Okay, so this will give you minus because I don't have any 99. Okay, so if you write like 5 here, okay, and also here search 5, then it will give you index. Okay, so at index 1 you can write here 0 1, so I got 5 present at index 1. Okay guys, this is for testing purpose. Okay, this is the object DLL of double linked list class. Here I am going to add element before the head, here I am going to add element after the tail. Okay, then it will traverse, so we can remove these things. Okay, so I got this output. This is the double linked list, and here we are going to search. So 5 presented 1, index 1. Okay guys, now we are going to move on get. Okay, so here I am going to define one function get self comma index colon. Oh, where is the get? This is the get function. Okay, get means what? Get means return the node at index. Okay, optimize the traverse from the head or tail and depending on the index. So we can find out the index, or you can say return the node at the index. If index is less than 0 or index is greater than equals to self dot length length, then it will return none. Okay, this is for invalid index. If index is less than 0, okay, it's mean you don't have any linked list. Okay, and it has negative index. Okay, and index is greater than equals to self dot length. Okay, then it is the invalid linked list. Okay, so we are going to return here none. Okay, again we are going to write another condition, that is index is less than self dot length length is divided by 2, then current underscore node equals to current underscore node equals to self dot head. Okay, but I forget current node equals to self dot head. So here I am going to use loop for dash in range range of index. Okay, 4 dash in the range of index, then I need to use colon here. Okay, then current node equals to current dot next, current node dot next. Okay, so here you can check here. Okay, so this is our linked list 10, 20, 30, 40, and 50. Okay, you can see like this. Okay, 10, 20, 30, 40, 50. Okay, we are going to find out its end. Sorry, we are these are the index of this. 10 present at 0 index, 20 present at 1, and 30 present at 2 index 2, and 40 present at index 3, and 50 present at index 4. Okay, and length of this is 5. Okay, so first condition, here you can see I have length equals to 5 and the index equals to 0, 1, 2, 3, 4. Okay, so this condition is invalid. Okay, this condition, index is less than 0, no, we don't have index is less than 0. Okay, and index is greater than this length of self dot length, no. Okay, we have index 0, 1, 2, 3, 4, and length is 5. Okay, so it will be none. And here index is less than self dot length divided by 2, means we are going to follow this table. So I am going to use get and index 1, what we have at index 1, so I use 1, get 1. Okay, so we can check here, index 1 is less than length divided by 2 equals to 2. So here you can see I have index, that is 1. Okay, is less than self dot length divided by 2. So here inside this table, okay, so 1 is less than length divided by 2 is equals to 2. It use forward traverse. Okay, so here after we got index is 1 and condition 1 is less than 2. Yes, 1 is length here. Here you can check, I have index equals to 1. Okay, 1 is less than length, that is 5 divided by 2. Yes, condition is true. Okay, condition is true. Then current node equals to self dot head. Okay, so what we have in current node inside this, what we have in current node? So head 10 is our current, or you can say head is also 10. Okay, so head equals to 10. Yeah. Okay, so we move in next step loop 1. Okay, so current dot next means next of element current, that is 20. Okay, so it will print 20 at index 1. So what I get at index 1, what that print output node, that is 20. Okay, I hope you got it. So here current node, that is 10. Okay, so current node, that is 10 here. Okay, and I'm going to use loop. Okay, so index equals to 1, our index value is 1. Okay, so we are going to use loop one time. Okay, so current node equals to current dot next means 20, so it will print 20. Okay, so it is not 320, it is 20. Okay, so if you have condition like this, index is less than self dot length or divided by 2. Okay, after this you need to use else condition. Else colon current node equals to self dot tell. Okay, so current node equals to self dot tell, means last element, that is 50. Okay, that is 50. Okay, now I am going to use loop for dash in range self dot length, length, length minus 1 comma index minus 1. Okay, so you can see here I have 4 index 0, 1, 2, 3, 4. Okay, and length is equals to 5. Okay, so we can check here get fourth element means last element in this case. Okay, so 4 is less than 2 is false. Use the backward traverse starting from the tail. Okay, so here we can check here. Okay, so I have 4 index. So 4 is less than 0, this condition will false. Okay, because 4 is greater than 0. Okay, and here you can check 4 is less than equals to 5 divided by 2. This condition is also false because 4 index is greater than this condition. Self dot length divided by 2. Okay, so these condition are false. Okay, so here I'm going to move here. Okay, now its range is equals to range self dot length minus 1. So I have length equals to 5, so 5 minus 1, that is 4. Okay, index is also 4, and minus 1 means we can step. This is for start, stop, and steps. Okay, and here I already add, I forget to add colon. Okay, so range is 4 comma 4 minus 1. Start, stop, and end. Okay, so here current node equals to current node dot previous. Okay, so I have current node that is 50 at index 4. Oh, sorry, here 4 is less than 2 false, and tail is equals to 50, and range is this. Okay, range this one start from the tail. Okay, now we are going to move. I'm going to use loop. Okay, so 50 current node that is 50, so no loop, no movement because I already at index 4, so it will return 50. I hope you got this line. You already on the index of 40, sorry, index of 4, that has at index 4 what we have 50, so it will print 50. Okay, and here I'm going to return current node. Okay, so guys, you can do it. This is the 2. Okay, length divided by 2. 5 divided by 2, I got 5. Sorry, I got 2 is a reminder, so you can check here 4 is less than 2. Okay, for this condition, so this is false. Okay, 4 is the index and length is 2, so 4 is less than 2. No, this condition is false. This condition is fail, that's why I moved here. Okay guys, and you can use, like if you want to like get index 3, so what we have at index 3, I have 40. Okay, so here you can use this condition also. So self dot tail equals to 50. Okay, and you can use this range. Okay, so current equals to current node dot previous means 40. So I got 40 here, and it will print 40 current node. Okay, here in this table. Okay, so tail is 50, and it moved from 4 to 3. Okay, previous node that is 40 and return 40. Okay guys, and here this is the object, sorry, this is the get method of double linked list. Okay, so if you want to print, then you need to use mhm. Okay, but we don't have any, we need to copy this. So in place of traverse, you need to write like this: get index 1, what we have at index 1. Okay, then you need to comment this. I already use search. Okay, so I need to remove this search, and I also need to remove this. And here you need to print DLL. Okay, I got error. Oh, I actually I haven't finished the insert code. Okay, so I got this. Oh, I need to comment this line. Mm-hmm. So what we have at it next one, it will give you 10. Okay, so if you uncomment this, you have linked list like this: 44, 5 and 10. Okay, so it will give you 10 here. Why? Okay, because if I am going to write like this: 5, 10, what we have at index 1, it is giving none. Okay, this is first element 44. Okay, guys, it is giving wrong. So what first element? What we have at index 1? What we have? If you are going to print DLL, that is 10. Okay, 10, 44 and 5. Now it is correct. So here you can print get 1. Get missing 1 positional argument index. Oh, I did mistake because of this. DLL should be DLL dot get. That should be 1 like this. Okay, I need to remove this. We can print like this. So yes, first element is 44, it is giving. At index 1 I have 44. Okay, at index 0 I have 10. So you can write like this. Okay, at index 0 we have 10, at index 4, sorry, at index 1 we have 44, and index 2 what do you have? 5. Okay guys, now it is correct. So you can print like this: DLL dot get and 2. Okay, and now we are going to move on set. Set means set the value, set the nodes value at the index to the value and return true if it's successful. Okay, so you can see here, this is our linked list: 10, 20, 30 and 40, and these are the index 0, 1, 2, 3. Okay, so we are going to set value at index 2, that is 99. So here in place of 30 I need to put 99 at index 2. Okay, so here in set I'm going to use one function def set value, set underscore value. Okay, here I'm going to pass self comma index comma value. So these are the parameters index and value inside this cell, inside the set function. Okay, here I'm going to create new node equals to self dot get. I am going to call get method. I have already explained this one. So self dot get equals to index. Inside this, I am going to pass index with the help of it. I got our index. Okay, so new node equals to self dot get. So what is the value of our index? I have index equals to 2, and I want to replace at index 2 with 99. Okay, so I have index equals to 2. Okay, so with the help of get, I got my index, that is 2. Now I have node. If node is present, then node dot value is equals to value. Okay, so here you can see node equals to self dot get to. So call the get function. Okay, from here, or from here, yeah, here. Okay, we are going to call the get function to fetch the node at index 2, and its value is 30. Okay, so index 2, what we have 30. So here node dot value, what we have 30. So here 30 will replace with the value, that is what, if node exit s, yes, node is exist. Okay, then 30 dot value means 30 equals to, I am going to replace it with 99. Okay, so here you can see node dot value equals to 99. Okay, update the value now. Before what we have 10, 20, 30. Okay, in place of 30 now 99 is coming. 10, 20 and 99 and 40. Okay guys, then it will return true. Return true. And here return false. If all condition is fail, then it will return false. Okay, so I hope you got it. So this is the set value at index 2. I set 99. Okay, and here set value is the method of double linked list. Okay, so now we can copy and use to print. Where is my set value? From here I need to copy this for testing. Okay guys, so I need to comment this. Okay, I also need to comment both of this. I already finished these things. Okay, I'm going to okay, now we can check. Okay, I got error because invalid syntax set and set equals to value. Oh, I removed this line. Okay, now set value is wrong. Okay, सही है. Okay, so in index 1, at index 0 I have 45, 44. At index 1 we have 5. Okay, so this is 0, 1 and 2. This is giving you wrong. So if you want to use append, well, we will check what is it giving you. This is the 5, 44 and 10. 5, 44 and 10. This is similar. Okay. Similar thing. I got it. Now if I'm going to change pretend. So here pretend are used to insert the element before the head. or you can say before the I mean start of the linked list. Okay, so it will our linked list is like this: 10, 44, and 5. 10 is present at 0 index, 44 is present at index 1, and 5 is present at index 2. Okay, so I am going to replace index 1 with 55. Okay, so here you can see at index 1 what we have 44. Now you can see here I have 45 after replacing this. Okay, so you can all change here by using this. I want 100 at index 1, so it will give you 100 here. Okay, at index 1. I hope you got it. Now we are going to move in insert, pop, and remove it. Before it, you can see search is used for find the index, or you can say return the index of the first node with the value, target, and else. Okay, and get method return the node at index and optimize it traverse from the head or tail depending on the index. Okay, I already explained everything. Uh, okay, so set value are used to set the node value at index to value. Okay, return true if successful. Okay, so now we are going to insert, pop, and remove and delete. 4 method is still left. So we have linked list like this: 10, 20, 30, and 40. Okay, I'm going to insert at index to 99. Okay, so here I'm going to define one function, that is insert self, comma, index, comma, value. Here columns, here if index is less than 0, or what, index is greater than the self dot length, means length of linked list. Okay, length. Okay, so you can see here I am going to insert at index 2. I am going to insert at index 2, that is 99. Okay, so index is greater than 2. Okay, that is not equals to 0. Okay, index again is greater than cell dot length. No, because I have index equals to 2, and length of linked list is 4 because we have 4 nodes or 4 element inside this. Okay, so this condition is fail. Okay, like if it is true, then you need to print like this: print error index out of bound. Okay, and return nothing. Now again I'm going to define one condition: if index equals to 0, means you have one element at index 0. Okay, then you need to use pretend, means add in the element before the linked list. Okay, in starting. Before the head means you need to add element in the starting. Oh, by using pretend, not append. Oh, bro, what I'm doing here? Prepend. Okay, prepend value. Okay, it is used to add the element before the, I mean, in the starting of the linked list. Okay, and it will return nothing. And here, elif, condition. I'm going to use another condition, that is elif. If index is equals to self dot length. Self dot length means we are going to talk about what? length. We are going to talk about last index. Index equals to length of linked list. Okay, so here you can see I have index 2. If you have index 4 here, and node also you have 4, so length equals to index. Okay, so you need to insert the element in this condition at the end of linked list. Okay, so here you need to use append. Okay, self dot append. Here I'm going to insert value. Okay, in the end of linked list and return written here. Okay, and after this, okay, I added element in the last, I add the element in the beginning. Okay, and this is for invalid index. Now we are going to add the element in the middle. So here this is used for a middle. I'm going to add the element inside the middle of linked list. Okay, so here I'm going to create new node, new underscore node equals to node, that is value, node has value. Okay, temp underscore node equals to self dot get. Here I am going to pass index -1. Okay, so inside the middle you can see this linked list. Okay, I am going to use index 2 and I want to insert 99 at index 2. What we have at index 2? 0. At index 0 we have 10. At index 1 we have 20. At index 1 we have 20. At index 2 I have 30. So in place of 30 I need to replace this with 99. Okay, so here our new node is 99. Okay, so temp node equals to self dot get index -1. So I have index equals to 2. So here I am going to use get at index 1, 2 minus 1. So I got 1. So at index 1 what we have? At index 1 what we have, guys? So temp node equals to get 1 means index -1 equals to 1 and temp node equals to 20. So at index 1 what we have? 20. So now temp node equals to 20 here. Okay, you can see here temp node equals to 20 and linked list is like this: 10, 20, 30 and 40. Okay, now new node dot next equals to temp dot next means new node dot next now point to the node 30. Okay, so new node dot next equals to 30. Okay, so after 20 I got 20. Now new node, new underscore node dot next, new node dot next equals to temp underscore node dot next. Okay, so here you can see new node, new node dot next. Okay, so 99, next of 99 I'm going to add this with the 30. Okay, so node now point to the 30, this here. Okay, so new node dot next, here we are going to add after index, like I already find index 1. Okay, so we need to stop here at index 2, 20. Sorry, at index 1, that is 20. So after 20, like this, I'm just giving one example. After 20, after 20, what is the new node? That is 99. Next means this line. Okay, so new node dot next equals to temp node dot next. So what is the next of temp node? What is the next of temp node? Okay, so it will become like this: new node dot next equals to now point to the node 30. So new node dot next equals to 30. Okay, so temp is 20. Our temp node is 20. So next of 20 is 30. Here temp node dot next equals to 30. This line. This is 30. Temp node dot next is 30. Okay. So here I got like this. Where is it? This one. 10, 20 and 99 dot next. Okay, so this line I need to copy. Where is it, guys? I am going to confuse. Okay, I need to keep this line from here. Okay, so you can use like this. In comment, I have 10, 20, and new node dot next. This one, new node is 99 and next, and temp node dot next means 30, and after 30 I have 40. Okay, so 99, meaning of this line, 99 dot next is equals to 30. Okay, and I have 20, that is temp node. Next of temp is 30. Okay, so after this, after this line, new node dot next, new node dot next, I am going to use this line, new node dot previous. So I am going to copy this line, and here I am going to write new node dot previous. So this is used for connect the previous arrow. New node dot previous equals to temp node. Okay, so in this line new node dot previous equals to temp node. Okay, so new node dot previous. Okay, so previous of 99, what do we have? So this is the new node dot previous means 20, 20. Okay, what do we have? 20. So we are going to add new node with previous point, that is 20. So here we are going to add 99 with 20. This 99 I am going to add with 20 here in this line. Okay, so new node dot previous, new node that is 99 dot previous is equals to 99. It is equals to 20. Okay, so here 99 will connect with the 20, and here 99 connect with the 30. You can see here 99 previously connect with the previous by using this with 20, and by using next 99 connect with the 30. Okay, so here in this line linked list will become like this. I need to copy this. Okay, so now everything is connected with linked list 10, 20, 30, 10, 20, 90, and 30. This line for connect the 30 with 99, and this line used for connect the 20 with 99, that is previous. This is for previous new node dot next. So this is our new node dot previous equals to 20, 20, and new node that is 99 dot next equals to 30. Okay, so we connect both line by using this and this. After this, after this, new node dot previous, new node dot previous equals to temp node. Now, temp node dot next dot previous equals to new node. New node dot next dot previous. New node dot next dot previous equals to new node. Okay, so 30 previous updated to the point to the new node, that is 90. Okay, 30 dot previous dot 99. Okay, so here 20, 10, 20, 99, 30, and 40. Okay, so here you can see this point previous by using this backward arrow connected with the 99. Okay guys, so this is the double linked list because that's why I need to write for both previous and next. I hope you got it because it is sometime confusing. Okay, now temp node dot next is equals to new node. Here I am going to connect 20 by using forward. Okay, so temp node dot next equals to new node. Okay, 20 dot next updated to the point. So new node that is 99, like this 20 next 99. Okay, so here 20 connect with the forward direction with 99. Okay, so this is for forward direction, new node, and here its length is increased by 1. Self dot length length increase by 1. Okay, and here in this line, insert is the method of double linked list. Okay, this is the object of double linked list. Here I am going to insert at index 1, that is 99. I am going to run this. Okay, I got error index out of 1. Okay, because I haven't add element. I need to add some element. Okay, still it is showing index out of 1. 0, 1, 2. Mm-mm. Mm. Here I am going to check again. New index equals to node value. Temp node equals to self dot get index minus 1, and new node dot next equals to temp node dot next, and again new node dot previous equals to temp node. Temp underscore node equals to next dot, sorry, temp node dot next, not dot previous equals to new node. Dot temp node dot next equals to new node again, and self dot length increase by 1. Okay, everything is right. Now this is the insert is the method of this double linked list. Okay, why I got error index out of 1? Mm-mm. Okay, I got error because I need to pass index and value. I already passed index and values. Okay, I need to check with this. I need to copy this. I need to paste it here. I got error definitely because I haven't used pop first. Okay, so I need to remove these things. Pop first because I haven't finished this. I use set. Oh, this is insert. Mm, this is should delete element. I need to remove this. I also remove this set. I also remove this. Okay, guys. So, I got linked list like this. Okay, so if I am going to comment this. Okay, so what I have 44, 5, and 10. Okay, so here you can see at index 101 I have 5. Okay, if I am going to comment it out, then I got 99 at index 1. Okay, guys, so this is working. I insert at index 1, that is 99. I insert 99 at index 1. Okay, I hope you got it. Okay, you don't need these things. I need to remove this. Now we are going to move on pop first. Pop first means we are going to delete first element from the linked list. Okay, guys. So here I am going to write one function that is pop first, pop underscore first, first. Okay, here this is self colon. If not, self dot head means if you don't have any head inside the linked list, then it will return none. Okay, guys. Then popped node, popped popped underscore node equals to self dot head because I want to remove first element, because pop first means you need to remove first element from the linked list. Okay, so here if self dot length length is equals to 1, if length of your linked list is 1. Okay, okay, then you need to create self dot head is equals to none. Okay, because I am going to delay it. Okay, so if you have one element, like if you have 20, okay, so then you need to replace this head, self dot head equals to none. Okay, and here self dot tail is also none. So you delete first element. Okay, okay, like if you have only one element that is 20, okay, its tail is also 20 and head is also 20, then you need to set this none, both none. Okay, then it will delete the 20. Okay, or if you don't have any like length equals to 1, or if you have head, okay, then both of these condition are false. Then we move in else condition, that is what this one. So here I'm going to write self dot head equals to self dot head dot next. Okay, so self dot head, what we have 20. I'm going to, sorry, inside the head what we have, sorry, I have 10. Okay, sorry guys. So I just need to remove this. So okay, now I have self dot head equals to 10 and popped node is equals to 10 because this is the first element. Okay, I'm going to remove this 10. Okay, so it is for like if you have any element, one element, then you need to set none for both head and tail, then you will delete it. Okay, by using this condition. Okay, now I have popped the node equals to self dot head, that is 10. Okay, this is deleted node. I am going to delete this node. Okay, pop first means we are going to delete first element. Okay, okay, you can see here self dot net equals to self underscore node equals to self dot head store the node 10 to return the later. Okay, so pop node equals to 10. Okay, 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 now you can check self dot length equals to 1. Okay, because we can skip this condition because we have four element. Okay, so we don't need to use this. In length we have four element. Okay, so we move here in this condition. So here self dot head equals to self dot head dot next. It mean self dot head equals to, before we have 10 in head. Now head will become self dot head dot next. Next element. What is the next element of head? That is 20. Now 20 will become our head. Head. So here our new head is 20. Okay. Now 20 is our new head like this, and linked list will become like this 20, 30, and 40. Okay. Now we are going to remove previous link. Okay, so self dot head dot previous equals to none, and no any none. Okay, this is self. Okay, so self dot head dot previous means we are going to remove this previous link from the 10. Okay, self dot head dot previous, so remove the backward link from the new head. Okay, so 20 previous equals to none, so previous link, this link 20 से जो प्रीवियस लिंक कनेक्ट है 10 से 20 से लेकर 10 तक, so I need to remove this link, this previous link. Okay, so previous link is none, so again it will become 20, 30 and 40. Okay guys, now popped node, PPOED popped node dot next. Okay, that is also none. Okay, I'm going to set pop node dot next means forward link. Pop node dot next equals to none. So detach pop node dot next is none. Okay, so I'm going to delete this 10 from here. So 20, 30 and 40 is still left here. Okay, and decrease its length by 1. Okay, because before we have 4 sides and we have 10. After removing 10, its length decrease by 1 and it will become 3. Okay, so here self dot len gth minus equals to 1. Okay, then return popped node. Okay, so it will return popped node, that is 10, and still linked list is like this 20, 30 and 40. Okay guys, this is the pop first method is the double linked list method. So here I am going to print again. Okay, so you need to copy this. Okay guys, I this is the object of this class linked list. I already mentioned in starting of linked list. Okay, and here we are going to pretend, append and insert. Okay, pop first I need to comment this because I haven't finished this. Okay, and delete also I haven't finished. I also remove this. Okay, we can check here. Okay, so these are the link list. This is the link list 40, 99, 5 and 10. Okay, we can also comment it out. I don't want to use these things. I already explained. These also. Set value also explain. Actually, I also remove these things. Okay, now it look fine. Okay guys, so I need to comment it out. Okay, so okay, so this is showing you same result. Okay, 44, 99, 5 and 10. Okay, now I comment it out. Okay, so after it I am going to rerun again. Okay, oh, I also need to comment it out. Then it will remove 44. This is the first element. Okay, because I use pop first. Okay, before it will give you what? Every element like 1, 5, 4, 10. Okay, so it will remove first element. Okay, and you got this one 99, 5 and 10. Okay, now we are going to move in pop. Pop means we are going to delete element from from the end. Okay, in pop first we deleted element in the starting. Okay, so here I need to copy this thing. Oh, why it is not moving? Okay, I need to copy this. Okay, I need to remove this first. Okay, so here in place of first, I need to write just like pop. Okay, pop self. If not, self dot head. Previously, I have self dot head because we are going to remove element from the head, or you can say from the start of the linked list. Now I need to replace this head with tail. Okay, because we are going to delete element from the last. Okay, it will return none. Okay, if you don't have any tail, then it will return none. Okay, pop node, previously we have self dot head, now it will become tail because we are going to delete last element. Okay, I also need to replace this. And what we have, popped element 40. Okay, so here I can comment it out. Popped element, that is 40. Self dot length equals to 1. Okay, so we have self dot length equals to 1. No, because length is 4. Okay. Okay, so if length is equals to 1, no, length is 4. Okay, so we need to skip these condition. If you have length equals to 1, then you need to delete like this: self dot head equals to none and self dot tail equals to none. You need to replace like this: head with none and tail with none. Okay, so we have length equals to 4, then we need to move here. Okay, so here's condition: self dot head. In place of head, I need to write tail. That is last element. Okay, tail. And self dot head, in place of head, I need to replace with tail. Okay, and next is replace with the previous. Okay, so you can see here I have last element at tail, that is 40, and previous element, that is 30. Okay, so now tail will become what? 30. You can see here now tail will become 30 here in this line. Tail is 30 because previous element of 40 is the popped out, and previous of 40, what we have? 30. 30 will become our tail. Okay, now we can set self dot tail. Self dot tail dot next is also none. Okay, it is like for next wire. Self dot tail dot next, because we are going to deattach 30 with, sorry, 40. Okay, self dot tail dot next is equals to none. Okay, and here pop node dot previous is also none. Okay guys, so previous, I mean, this is 4. Here you can see I have tail, that is 40. Okay, and 30 dot next, I am going to remove this connection, backward wire, sorry, forward wire. So 30 dot next means tail dot next also none, and pop node, that is 40. So here you can see tail dot next 30, that is 40, and previous of this tail, this is 30. Okay, so I am going to remove this wire, or whatever you say, so we can disconnect. And length is decreased by 1 because we removed and written pop node. Okay, so I hope you got it. Now we can remove the element by using this. Okay, so here pop equals to pop, that is the method of linked list. Okay, it is popped. No, it's popped. Okay, this is the object of double linked list class. Okay, so here I need to remove this. In place of this, I need to write like pop. I need to like this. Oh, why it is not going to remove? This is pop. Okay, so first of all, I need to check. I need to comment these two lines. Okay, so what we have in my linked list: 44, 99, 5 and 10. I also need to remove this line. Okay, I don't need to insert. Okay, so I have 44, 5 and 10. 44, 5 and 10. Okay, 44, 5 and 10. Now after going to delete, what is your output? Okay, so popped and remove, pops and removes. Okay, so I got 44 and 5 and remove the 10, that is last element. Okay, so this is our result. Okay guys, now we moved on remove. Okay, so here I'm going to remove the element, so I use remove method. What is the remove? Remove index, remove a node at a specific index. Okay, so here remove, I'm going to pass self comma index columns. Okay, if index is less than 0, index is less than from 0, or index is greater than equals to self dot length length, then return none. Okay, like if you have index is less than 0 or index is greater than equals to length of linked list, then we need to return none because it is for invalid index. Okay, you can say if index equals to 0, index equals to 0, it's mean we are going to insert in the starting. Okay, starting of linked list. So here I need to return, I hope, I think I already explained these things. Let me check. Okay, in insert, I use this. No. Let me check. Okay, now we are going to remove, I'm not going to insert. Okay, so if index equals to 0, then it will return last element by using pop self dot pop underscore first first. Oh guys, sorry. If index is equals to 0, then you need to add element in the first index. In the I mean, if index equals to 0, then it will return self dot pop first, means it will remove the element in the beginning of linked list. Okay, first element of the linked list. Okay, so I'm going to use pop first. Or here, if index equals to, I need to copy this line. If index equals to self dot length self dot len gth self dot length minus 1. Okay, if index equals to self dot length minus 1, okay, then it will return self dot pop, means last index. It will give you last, I mean, it will remove last index. Okay, by using pop, and this will remove first index, I mean first element, not index. Okay guys, sorry. So this will remove first node and this will remove last node. Okay, if index equals to length. Okay, like if you have 3 nodes inside the linked list, okay, and you want to delete, sorry, and you also have index equals to 3 that you want to delete. So 3 equals to 3, then it will remove the last element. Okay, and if you have index equals to 0, means this is the first node and it will delete the first node here, and this is for the invalid index. Okay guys, now after this I am going to remove from the, okay, so this is for, I already explained, this is for invalid index, and this is for you want to delete element from the starting of the linked list, and this is for if you want to delete element from the last. Okay, now popped node. Okay, pop node equals to get index. Okay, so we are going to use its length is 5 because we have 5 node 1 2 3 4 5. Okay, and we remove index 2, that is value 3 30. So I am going to remove 30. So this is for middle index. So 30 is present here in the middle and its index is 2. Okay, so here I am going to write popped node, pop pped, popped underscore node is equals to self dot get. Here I am giving index. Okay, so I have index equals to 2. Okay, with the help of get method I got my index. Okay, where is this line? Get index 2. So node 30. So at index 2 what we have? 0 1 2. So at index 2 what we have? 30. Okay, so I got 30 here. Okay, node equals to 30. At index 2 I have 30. Pop node. Okay, now popped node dot previous dot next equals to popped node dot next. What is the meaning of this line? Here you can see pop node means 30. This node we are going to remove 30. Okay, pop node dot previous. What is the previous element of pop node? 30, that is 20. Okay, pop node previous and next. Okay, so here pop node dot previous dot next. Okay, so 20 is the previous node. Okay, so here 20 dot next equals to, in this line guys you need to understand 20 dot next. Okay, so from the pop node dot previous what we have? 20. So 20 dot next is equals to pop node dot next means next of the popped node. Okay, so next node of the 30 is, that is 40. Okay, so I am going to connect this 20 directly with the 40. Okay, so we need to skip here 30. Pop node, that is 30. So previous of 30 what we have? 20. So 20 dot next, it's mean we have 20 dot next connect with the pop node that next of 30 we got 40 here. So I am going to directly connect with 20 with 40. Okay, I skip 30 here. I connect 20 this 20 with this 40. Skip this 30. Okay, so here skip 30 and 20 dot next 40, and linked list now become like this: 20 30 and 40 and 50. Okay, so I need to copy this line from here. Now linked list will become, okay, so this is our new linked list after removing 30. I connect directly 20 with 40. Okay, so this is our new linked list. Now, no. Pop node, pop node. In place of previous, I need to write next. Next and here previous. So pop node dot next. Okay, so what we have? 40, 40 dot previous. So in this line, 40 dot previous equals to 20. So here 40 dot previous is equals to 20. Wait a minute. So pop node dot next means next node of 30. That is 40. Okay, so 40 dot previous equals to pop node dot previous. So what we have? Previous of pop node. So previous element is 20. Okay, so we are going to connect this wire. Okay, we are going to talking about this wire. Okay, so this is for next. Okay, forward wire for next and backward wire for previous. Okay, so here 40 connect with the, because we have arrow here, you can see 40 can connect by using backward arrow with 20. Okay, so this means this thing. Okay, and here you can see in this line, in our line, 20 connect with the 40. So in this line we are going to connect 20 with 40. Okay, by using this direction. This is a forward direction. Now I am going to connect 40 with 20 by using this backward direction. Okay, and after this our link list has two arrow like this. Okay. Now pop node dot previous here, pop node dot previous node of pop node will become none because I already remove pop node, and I want to remove its wire also. You can say forward direction. I want to remove both direction, forward or backward. You can say it is previous direction and next direction. I need to set both none. Okay, and here its length self dot length is decreased by 1. Okay, and return, I'm going to return pop node. Okay, that is 30. Okay guys, so here after this length decreased by 1, previously I have 5 element, now it will become 4, 10, 20, 40 and 50. I remove 30 from here. Okay, and return pop node is 30. Okay, final linked list like this: 20, 10, 20 and 40 and 50, whatever last day. Okay guys, so if you are going to print, so you need to copy it and paste it here. Okay, so it's mean, this line mean remove is the method of double linked list. Okay, and here this is the class, sorry, this is the object of double linked list class. Here we are going to add the element. I need to remove some element. Okay, I am going to search delete whatever. I just need to write remove here. I'm going to remove everything. I also remove this delete. Okay guys, so here I have element. Okay, so I have different element 5, 4, 44 and 10. Okay, I just need to comment it. Okay, now I can run this. So I got 44, 5 and 10. Okay, if I'm going to write like this and uncomment this, then it will delete. Okay, and it will delete first ellipse, first index. Okay, that is what we have at first index. I have 5, then it will give you 44 and 10. Okay, so this is 4, sorry, how it will remove from index 1. Okay, if I am going to use only these things, so okay, so now you can see it will delete only remove. After popped and remove, I got 54, 44. Okay, so if you use append here, like this, so what is it is going to remove? It is not going to remove. Now we can check. It is not going to remove. What happening here? Okay, if we are going to use pretend, okay guys, now it will remove 5. Sorry, not 5, 44. It is the index 1. It is present here at index 1. Now we are going to move on delete. This is the last. Guys, I am tired. Okay, so this is for delete the element from the linked list. So here I am going to define one function, that is delete all. Delete all underscore all. Okay, here this is the function name. Here I'm going to pass self columns, and here if you want to delete head, then you need to set self dot head, that is none. So your head will be delete, not your head, linked list head will be delete. Okay, so you need to set this none. Okay, so if you want to delete tail from linked list, so you need to set this tail also none. That will delete your tail, not your tail, linked list tail. Okay, and you need to set self dot length length is equals to 0. Okay, okay, so it will delete everything, guys. Okay, so you need to copy everything. This is for testing purpose, guys, I already mentioned. So here it will delete all. Here you can see in the result it will delete everything. Okay. Okay, guys, so here insert method, insert a node at a specific index. Pop first means remove and return the first node. Pop means remove and return the last node. Remove index means remove the node at a specific index, and delete all means clear the entire list. Okay, guys, I already finished everything. I hope you got it. Okay, sometime it will be confusing, but you should understand everything. Okay. Now I have finished 2 hour and finished circular linked list, circular double. Sorry, now my brain is not braining. So now I have finished double linked list. Okay.